Hi guys, so today we will be doing the Leetcode problem, container with most water. This is the problem number 11 in the Leetcode. So the question says you're given an integer array, height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height dot I. Find two lines that together with the x-axis from a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, so for our example, we're given this array. And the array contains the height of each bar. And it says our output is 49, and the explanation says the above vertical lines are represented by array. This array. In this case, the max area of the water, blue section, and the container can contain is 49. Okay. So for this problem, we're given an array with heights of the bar, and our output is to figure out the area of the rectangle. We'll find out the max area of the rectangle that can hold water. Okay, so our constraint would be to make it optimize. So our edge case could be, I guess we could have a case where the height, the area, the array could be, length could be 1 or 0, but in this case they're asking how much water it can hold, so I guess it doesn't make sense to not have any array and only having one element. That does not make sense, so I'm just going to leave the edge case this empty for now. So I guess the simplest way we can try to solve the problem is by checking every single scenario, right? So first, basically comparing, starting with the left and comparing the whole thing, and then moving to the right, comparing the whole thing, and so on. So first, if we were to solve this problem that way, what we have to do is take two for loops, and then have one start with 0 index and another with 1, and iterate through every single bar here and figure out our max area. But that would result in n square time constraint. So we do need to optimize, right? So let's see if our the simple or brute force way of solving would solve this problem. So let's say let max equals to 0, because we're trying to find the max value. And then what we're gonna do is use two for loops. So let's say let I equals to 0, I is less than height dot length I plus plus, and you would do the same thing, but with the j we would say when j is less than height dot length j plus plus, right? So in here, in order for us to figure out how much water these two bars can hold, we need to pick the lowest height, because it doesn't matter how high one side is. If the other side is small, the water is not gonna hold, right? So our smallest is the height we need to take. So the way we calculate the area is basically by doing width times height, right, for the rectangle. So in this case, our width would be actually the difference between the index of right side and left side, or in this case, difference between two bars, right? So if we were to do this one and this one, the height would be 8, I believe. Let's see, 1 2 3 4 5 6 7 8 9. So since our index starts with 0, the height would be 8. So here we start with 0, and here it will be 8. So 0, 8 minus 0 is 8. So in this case, our width would be 8. But as for a height, height is 1. So it would be 8 times 1 for our first case. So let's say let area equals 2. So we said less width equals to j minus 1, right? Let, not 1, L. Let height equals 2. So in this case, our height would be height math dot min height comma height I comma j. So this would give us the minimum height between the I and the j. And then our array, area equals 2 times h. Then our max would be mat.max. So you would just compare the area with the max itself. And at the end, we would just return the max, right? So in this, what we're doing is computing what our width is. That's the difference between the index between two bar, and comparing the heights. So basically one bar versus another. So like we said, we always need to pick the minimum height, because that determines how much water it can hold, right? So if we were to run this code, let's see if it works. It would pass this array, right? But as our array gets bigger and bigger, our search for the area that holds the water also, like, it increases the amount of time it takes for us to find that. So if I were to submit the problem, I would get time limit exceeded. So keep going. Yeah, so it's not that our solution is wrong, it's just that it takes a long time for it to iterate through every single possible scenario and try to find the max, right? So what we have to do is find a better way to do this. Okay, so let's try to comment this part out. So what we have to do is, what we can do is pick 2 pointers, right? So we can start with left from the left farmost and the right on the right farmost, right? And then we can basically move the position of the left and right depending on what height is bigger. So what I mean is that we would just start left on the index 0 for now and right on the height length -1, so the far rightmost index would be the right. So we would basically compare the area between this area or the next area. So what we would do is say if one side is smaller than the other side, then we would just move the left side to the next round. So we can do the same thing where if the right is smaller, then we would move the right to the next index. The reason we want to pick the smallest one to go to the next round is because we want to find the max height, so that we want to find the max height. That means it will hold more water, and also that we want the max width, since our array is calculated by doing max height and width multiplication, right? So if we do that, then since we're starting with the far points, we would have the max width, right? We just have to now find the max height. That would give us the answer, right? So let's start coding this up. So what we can do is, I have already assigned the max to be 0 for now, because area, it can't be negative, right? It has to be some sort of positive number. So what we can do is, let's assign let left equals to 0, let right equals to height dot length -1. Okay, so in this case, what we can do is we'll make a while loop. Left is smaller than the right. So we want to keep going through this loop until left and right are on the same point, or left is smaller. So hang on, let me say that again. So we want to keep looping through this loop until the left is smaller than the right. So if there's a point, if the left is bigger than the right, then we have gone too far, right? We would have crossed over the other side. So we want to make sure that we only go through this loop until the left is smaller than right. Okay, so in this case, what we would do is we would have to figure out what our width and what our height would be. So we can say let width equals right minus left, right? So we're doing right minus left because we know that the right would always be bigger than left, at least according to our condition, right? So less height equals to, so we said earlier that our height has to be the minimum number between two bars, because it doesn't make sense for us to pick the max because our limit will be the minimum, right? So what we can do is we can do mat.min, pass in height left, comma height right, and our area would be width times height. Okay, so now we need to have a condition, like I said. Since our goal is to find the two bar that would hold the most volume, we have started from the far most left and far most right of the bar graph, right? So since our goal is to find the most area that holds the most water, we also have to think about the height. We need to try to see if we can find the largest height, right? So in this case, let's say we have start the left with the height of 1, and we're starting here with the 8. So in this condition, we would have area to be 1 times, so the difference between the index 0 minus 8, that would be 8, so area would be 8. So after we calculated that, we need to go to the next round. So in this case, what we would do is go to, since our left is smaller than the right, we would make our left move to the right most next step on the right. Again, it's because we are trying to find a height that's the tallest, right? And then we would calculate the area between this red bar and this another red bar. So in this case, our index is 1, and in here is still 8. So the difference would be 7. And since we said that we would pick the minimum height between these two, because that's much water it can hold, we have 7 as a height as well. So if we do width times height, we would get 49. So that would be our answer. So if we keep doing that, then we would at the end find the max array, right? So what we would say is, if height left is smaller than height right, then what we would do is increment the left side. And on the other side, if the height on the right is smaller, what we would do is we would actually decrement the right. So see, the reason we are decrementing the right is because we already started with the rightmost, so we need to go forward, right? For us to go forward, we need to decrement the index, since this one is 8 and this is 7. So if there's a case, if they have a same height, it does not matter if you increment the left or decrement the right. So with this condition, I'm just picking right to decrement if the heights are the same. Okay, and at the end we would just return. Okay, so I missed one part. So we actually need to figure out what our max would be. So max equals to mat.max, and then we would pass in max comma area. So this one would basically pick the largest area. So we start with 0, but for our first round, like I said, our area would be 8. So the max would be replaced by 8. And we'll keep doing that and storing the max as a max value until we get our max value, and then we will just return max. So let me quickly look over and check if I miss anything. Height, okay. Mid, okay. Area, width times height. Area, okay. Let's try to run this code first. Okay, and let's try to submit it. Okay, so this works. So this one would be much faster than solving it other way, because the other one was causing us to limit time. So hopefully that made sense to you guys. While I was doing this problem, I did try to use the brute force method because I thought that was the easiest, and I just had to run to see if it will pass at all. And it did pass the first case, and when I tried to test it, it didn't pass. So I actually had to go back and try to find a more optimal solution. And yep, so this is the one that works.